Okay, so these are the notes for the absolute value function. It says the parent function of the absolute value function is f of x equals the absolute bar x, absolute bar. The sample absolute value function, not f of x equals the absolute value of x, so not the parent function, is sketched below in figure 1. So first we're going to talk about creating the actual parent function. So it says graph the function f of x equals the absolute value of x. So we're going to take -2 and plug it in here. So the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. Absolute value of 1, absolute value of 2 is 1 and 2. So now we're going to plot these points. So -2, +2, -1, +1, 0, 0, and 1, 1, and 2, 2. And so now we have this shape coming here. Sorry, I missed the points. Identify the domain. So from left, this heads towards -infinity. To the right, this heads towards +infinity. For your range, bottom to top, this is a closed circle, so that's a bracket at 0. And these arrowheads both goes towards infinity. Find the x-intercept. Well, it's at the origin right there, so where it crosses or touches the x-axis, 0, 0. And the y-intercept is also at the origin, 0, 0. So just recall that the absolute value is the distance that any number is from 0. That's why the numbers always appear to be positive. All right, here, this is the figure 1 that was talked about in the very beginning. So this has a restricted domain because it's not going towards negative and positive infinity. So first thing says, number 6, identify a reasonable domain for the function in figure 1. Well, closed circle at -3 and open circle at 6, which is a segment. So -3, 6. -3 is a closed circle, that's a bracket. 6 is an open circle, that's a parentheses. For a reasonable range, the lowest part is this closed circle here, not the endpoint. And this one, the endpoint is the highest point, which is a closed circle here. This is at -2. This is at +4. So -2, 4, bracket, because they're both closed circles. Is there any x-intercepts? If yes, what is /r it/they? Okay, so we can see we intersect right here, and the coordinate for that is going to be 1, 0. And we also have one here where it intersects the x-axis, which is at 5, 0. What is the y-intercept? We can see it intercepts here, which is 0, 1. Okay, next thing says, how does changing the number in front of the absolute value of x affect the graph? And we have a. So let's kind of talk about the transformation equation. There's my a, there's h, and there's k. So how does a affect it? So we'll change this to the color red, so it's color specific. So if a is greater than 1, it is a vertical. So let's call it a vertical stretch by a, if a is greater than 1. Vertical compression by a, if a is less than 1 but greater than 0. And a reflection across the x-axis if a is less than 0, which just means the value becomes negative. All right, for the next one, h, I'll do this one in blue. We can see that it is inside with the x. So how does adding or subtracting a number inside the absolute value of x affect the graph of h? Well, we know that it moves left and right. And once again, it's the appearance. If I'm looking at it, it's the opposite. But we know that if h is negative, it goes left. If h is positive, it goes right. But when we look at it, it's the opposite of what we see. The k we'll do in green, and that's pretty straightforward. K can go up or down. And this one is pretty true. If k is greater than 0, it goes up. If k is less than 0, it goes down. All right, then we have this example here. It says graph the function g of x equals negative x plus 3 minus 4. So first thing we probably need to do is talk about the transformations here. So we see that this negative sign right here reflects it across the x-axis. This moves it left 4, and this moves it down 4. So in terms of x, the only thing that's affecting it is this left 4. So the row would be that's left 3. So the row would be x minus 3. And then here we can put a y through here, and we see that it's negative y minus 4. So we multiply the y values. We take the opposite of each y value first, or multiply by negative 1, and then we take away 4. Okay, and the points that we're going to be manipulating are going to be that original parent function table, which is right here at negative 2, negative 1, 0, 1, 2, 2, 1, 0, 1, and 2. Okay. So for the first one, this is going to be, let's see, it's going to be negative 2 minus 3, negative 1 minus 3, 0 minus 3, 1 minus 3, and 2 minus 3. So this would be negative 5. Negative 1 minus 3 is negative 4. Negative 3, negative 2, and negative 1. On the other side, we're taking the opposite of each value. So the opposite of 2 minus 4. The opposite of 1 minus 4. The opposite of 0 minus 4. The opposite of 1 minus 4. And the opposite of 2 minus 4. So the opposite of 2 is negative 2 minus 4 is negative 6. The opposite of this is negative 1 minus 4, which is negative 5. It's negative 4. Opposite of 1 minus 4 is negative 5. And this is negative 6. And now we can graph our function. So negative 5, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. So notice I did plot this. Let's try this again here. 1, 2, 3, 4, 5, 6. This was 5. This is negative 3, 1, 2, 3, 4. Negative 2, negative 5, and negative 1, negative 6. And we make our graph. You have to realize that it does keep going, does not stop. There are no restrictions on the domain here. All right. Now identify the domain for this function. We can see negative infinity, positive infinity. And for the range bottom, these both head towards negative infinity. And we stop at this closed circle right here, which is negative 1, 2, 3, negative 4. So negative infinity to negative 4, least to greatest. Bracket on that negative 4 because it is a closed circle. Find the x-intercept. There is none because it does not cross or touch the x-axis. You can write none, does not exist. Find the y-intercept. We see it intersects at this point here. So that's 1, 2, 3, 4, 5, 6, 7. So 0, comma, negative 7. All right, let's keep going. All right, and for these last ones here, we are going to talk about the transformations, create a table, and write the domain and range. Okay, so for this first one here, 3 times the square root, or 3 times the absolute value of x. So since that's an a value, and it is greater than 1, that is a vertical stretch by 3. In terms of the table, the x values will not be changing, but the y values, we're going to multiply each one by 3, so 3 times y. I'm going to go ahead and write the parent function table up here. So this is the original table, so negative 2, negative 1, 0, 1, 2, and 2, 1, 0, 1, 2. So the x values we can see are not changing, so negative 2, negative 1, 0, 1, and 2. Whereas these we multiply by 3. So 3 times 2 is 6. 3 times 1 is 3. 3 times 0 is 0. 3 and 6. Now I do have my domain and my range. So since there are no restrictions on the domain, regardless of how you move it, up, down, left, right, stretch it, compress it, reflect it across the x or y axis, the domain actually will not change. That will still be all real numbers, okay? And a way to double check this in the calculator is to do this. You can just type this function into your graph. So If you're not familiar with how to use this calculator, you turn it on, you go to y equals, and it says 3. And if you're going to do the absolute value, let's see if we can do this here. Let's see. Usually I just go second catalog. Oh, absolute value, X. Where is X? Arrow out, enter. And then there's this button that says graph right here. You press that and it graphs it for you, and you can see that it is vertically stretched a little bit, so it becomes more narrow, still facing up, so negative infinity to positive infinity. Also, you can see now that the lowest part is 0 and it heads towards infinity. Now, really quickly, this is 0 to infinity. We know that 0 is included, so that is a bracket. Now, things that affect your domain. So let me talk about that. I should talk about that first, but here, domain's going to be affected by actually nothing. Nothing should affect your domain and range because your domain, because there are no restrictions. For your range, it's going to be your left and right movements and your reflections across the x-axis. So that's what affects your range. The domain, since it goes all real numbers, nothing will change that unless it's restricted. Okay, so let's take a look at the next one now. So this a value is less than 1 but greater than 0. So that's going to be a vertical compression by 1/2. So x, once again, is not being affected in any way, but the y values will be taking 1/2 of each y value. So -2, -1, 0, 1, and 2. Half of 2 is 1, half of 1 is 1/2 or 0.5, half of 0 is still 0, half of 1 is 0.5 or 1/2, half of 2 is 1. So domain, once again, we said nothing will affect that. And in terms of my range, there were nothing moving at left or right or reflection across the x-axis, so it should still be 0, infinity. Another way, you can just check that again. So if you still need practice with this, you go to y equals. I'm going to press clear to clear that out of there. And my equation is 1/2 the absolute value of x. So 1 divided by 2. And we're going to do second catalog. Absolute value shows up immediately. And we type in x. And there we go. And the graph should be getting wider when we press graph. And there we go. So it has gotten wider. So that's a vertical compression, squishing it vertically. Oh yeah, and domain, all real numbers, range 0, head towards infinity. All right, let's take a look at number 3 here. So for number 3, we do have 2 transformations. This is h, it's moving left to right, so the opposite of that would be -1, so we know that it is left 1. And this is k, so this was h, this was k, it's -4, so we know it moves down 4. And usually I don't write out the whole word, I just put the letters, but since I wrote it all, I'm going to have to stick with that. Okay, so x is affected by left 1, so that's x -1. Y is affected by down 4, so that's y -4. So each x value, I'm going to take away 1. So -2 minus 1 is -3. -1 minus 1 is -2. 0 minus 1 is -1. 0. And 2 minus 1 is 1. All right. For my y values, I'm going to take away 4 from each y value. So 2 minus 4 is -2. 1 minus 4 is -3. 0 minus 4, -4. 1 minus 4, -3. And -2. All right, so for domain, we've already talked about this several times now. It should still be all real numbers, -infinity to infinity. My range does change now because since I went down 4 units, instead of starting at the origin 0, 0, it's going to start from -4. And we always include it because it's a bracket there because it's a closed circle. And it still heads up towards infinity because it didn't reflect across the x-axis. If you are curious to see what this looks like, let's take a look here. So here is my y. So I pressed y equals already. I cleared it out. My equation is the absolute value of inside x plus 1, arrow out, -4. Enter. We're going to press graph to see what it looks like. And there it is. We can see it's been translated down 4 and left, or left 1, down 4, whichever way. But we can now see it's from -4 to infinity for the range, and the domain is still all real numbers. All right, we're down to the last one here. This one's a little bit tougher, and it's different. The way you would go about this is most people think it's right 8, but you do see there's a b value in front of x. So what we need to do here first is factor. So we're going to take out the 4 out of the x minus 8. So it's a common factor. So if I factor out a 4, divide this by 4, we get x. Divide this by 4, we get -2. Close that, plus 2. So now we actually have 3 transformations here. The first one, since there's a 4 in front of the x, we take the reciprocal when we get 1/4. And 1/4 is less than 1, so that's a compression. And since it's inside with x, that's a horizontal compression by 1/4. Now that we see -2, it's no longer -8, which would be right 8. It is -2, which is right 2 units. And last, we have this k value outside positive, so it goes up 2. All right, so the rules here for x. Well, we're going to multiply by 1/4 first. And then we're going to write 2, so we're going to add 2. For the y values, up 2 means to add 2. Okay, so this one's going to be a little bit different. So let's see. So my value, let me write the table here so you can see it. This is the parent function table. I'm going to do the y values first because just adding 2 is pretty easy. 2 plus 2 is 4. 1 plus 2 is 3. 0 plus 2 is 2. 3, and 4. All right, now let's take a look at the x values. So 1/4 of -2 is -1/2. Plus 2 is 1.5. So just to show you, I would just do 1 divided by 4 times -2, close parentheses, plus 2. And once I hit enter, 1.5. And then now I'm going to just go back up and change that to -1, which should be 1.75. Then I'm going to do 0, which should be easy. I mean, should just be 2. And then we go to +1, which would be 2.25. And then we go to 2, which should be 2.5. All right, and there's my table. Now, just so you can see what it looks like when it's graphed. First off, we should already write the domain because we know that's going to be all real numbers unless there's a restriction. For the range, really quickly, horizontal compression by 1/4 does not affect the range. Right 2 does not affect the range. Up 2 does, because now it moved the y values up 2 units. So now I'm starting at 2 and headed towards infinity. Bracket for the 2 because it is the closed circle as the vertex or the endpoint. All right, and then when we type this in, so let's see what this looks like. For x -8, arrow out, plus 2. And let's go and take a look here at the graph. So we can see it has moved to the right, so 1, 2 units. That's how I got right 2. It went up 2 units, which is right there. Now remember, the horizontal compression by 1/4 squeezes it together. And our domain looks good, domain range.